Good morning, everybody. Good morning. Highball energy. Oh, we need coffee. And I got an acai bowl coming. I ordered an acai bowl this morning. I had an acai bowl last night. It was so good. And I was like, could I order another one this morning? And the answer is yes, because I'm an adult. So, we're going to write some noob tutorials today. We'll see if anyone's actually here. Hello. So if you didn't hear the news, we raised money. This is a real screenshot of my bank. It's actually higher than that now, because the Tiny Corp is a profitable company. Marginally, but yes, we are actually profitable because we sell tiny boxes. So if you're interested in pre-ordering a tiny box today, it's just $100 with a pre-order. They're $15,000 and they'll be able to run Big Llama. It was described to me as a luxury AI computer, and that is exactly what the tiny box is going to be. Yeah, so we're going to try to make a noob tutorial today. You know how I generally feel about noob stuff, but I think it's important that, look, one of the goals of tinygrad is to have a developer experience that's just above and beyond what you can do. Look, you have a lot of choices in machine learning frameworks. But, okay. So first off, let's start by deleting broken docs. That doc doesn't even exist anymore. And then let's make a new one. We'll call it tutorial.ipynb. Like, notebooks kind of load in here, right? All right, this is cool. Honestly, that programming challenge, I got so many bad responses to it. I got people who didn't read the fucking challenge. Like, the challenge is not to, the challenge is write a Winograd. The challenge is write a Winograd conv, target a specific architecture, and get the maximum theoretical performance on that architecture. People thought the challenge was write a Winograd conv. This is not the challenge. That is easy. You can copy, ChatGPT can do that. Now, find an architecture, do some research into that architecture, be like, well, here's how many ALUs it has, here's how much memory bandwidth it has. So also, like, there's people who think, I'm even going harder with this at the Tiny Corp than I did with Comma. There's people who think there's some like separation, right? There's like a separation between consumers and businesses. There's like a separation between employees and executives. There's not, okay? It's all a spectrum. If you're trying to play some adversarial game with me, like you're giving me some half-assed solution, and you kind of know it's half-assed, and you think you're just trying to like play a game to like, oh, well, I'll get my foot in the door, then get the fuck out of here, man. Like, don't waste my time, don't waste your time, have some self-respect, have some goddamn self-respect. So yeah, if you're not going to do great work, don't do it at all. There's my high school yearbook quote was, if something's worth doing, it's worth doing well. There's just a lot of things not worth doing. So yeah. So let's go into the noob tutorial. There's also a change I want to make. I want to be able to set the how many pre-orders for tinybox? Almost 100. We got a lot of tinybox pre-orders. Alex is helping the Tiny Corp out with a logo. These things are gonna look sick, guys. Like, we're gonna make awesome looking tiny boxes. Some guy posted on Twitter a comparison to our equivalent Lambda Labs machine. You get like 2x as much. The order link is on tinygrad.org. You can find it. It's a $100 pre-order, and then it's going to be $15,000 total. Maybe it might be more. It probably won't be more. If you actually put a pre-order in, I'll probably honor the price. but I've run into some issues building these things, and I'm going to have to use more expensive parts than what I thought. So, yeah. Yes, it is. It is $15,000 with 3 zeros. Okay. So one of the changes we're going to have to make. Well, let's start with the tutorial, okay? So all tinygrad starts with is import tinygrad.tensor. Sorry. From import tinygrad.tensor import tensor. Right? This is like the import numpy as MP for tinygrad. Wait, what? All right, you see it imports in 1.2 seconds, which I guess is pretty good. Okay, let's create a tensor. So what kind of tensor do we want to create? Where do we want the... No, it's not TG. It's this. I think I can actually, if I do it in init, I could get rid of that .tensor, and maybe we'll do like from tinygrad import tensor, but really tensor is how you control the entire thing. So I can say something like a equals tensor. Let's make a tensor of 1s. Let's make it 10 by 10. All right. Look, you can tell this is a noob tutorial because I made the font big. So what does that actually mean? So yeah, you see a whole bunch of confusing garbage when I type that. If you do .numpy, it will turn it into a numpy for you. And you see the D type is a float 32. You can also, from tinygrad.helpers import D types. You can also change the D type. Let's say D type equals D types dot float 16. And now it's float 16. But we won't do that. Okay. So we have a beautiful tensor. We can multiply it by 4. Now again, you'll see that I should probably make this nicer. It's a tensor backed by a 10 by 10 lazy buffer, float D type, a mul, and then some things about the shape, where it lives. It's on the GPU, and the grad is null. So again, if we want to actually realize that, we can do a.numpy. Now, I want to try something that I don't think is going to work. If I say debug equals 2, it's not actually going to debug equals 2. Yeah, we need a setter for debug, but I'm not even sure this is how these things work. Like if I write set debug, yeah, set debug doesn't actually work, unfortunately, because it's imported. How do you move the tensor to GPU? Well, it's on GPU by default, but if I want to move it to CPU, I can. We'll get there. I don't like that you have to restart in order to use debug, and I use debug everywhere. Is there like a way to do this? You see the problem? So one thing that does work is you can do this. This font size is horrible. I made the font so fucking big. That's not big enough for you? So I can do os.environ sub debug equals 2. this is going to work. Okay, so you can see here that it printed out this. And when I do this, you see that it printed out this here. Now we need a way to set debug dynamically. No, that works, but the problem is I can't change it. All right, bro, even though you're a subscriber, you're getting timed out. You're shilling for someone else. Who are you shilling for? You are the reason we're about to go sub only. Ethan1G knows what's up. Okay, cool. So only subs get access to this great noob content. It's gonna be a big change. Like, can I make a property, but a global property? Oh, interesting. Okay, so what if I do import helpers? Does this work? And then I say helpers.debug equals 3. Or let's say 0. No, see, it doesn't work. I can't assign to it. Because I guess when I import it, it makes a copy. Do you see the problem? You misunderstood how variables work in Python. Variables are not memory locations. You should read more about... Oh, this is terrible. So, okay, I have a lot of places in tinygrad where I import debug. Like here, from tinygrad helpers, import debug. But the problem is then there's no way to change that. Yeah, there's a logger module. I kind of hate the logger module. Should we switch to proper logging? Use data classes? No, this isn't really what I want. I don't think there's a way to do what I want. Like, I could make that a function and then access a variable. Maybe I have to. Like, I could just do this. It's kind of terrible, though. But I guess the minute I've done that, it's already made a copy, right? It's brought debug into my local space. Okay. Well, we have os.environment for now. Cool. So let's look at a few interesting things, right? So if I do something like a times a times a dot numpy, so it's 1 times 1 times 1. It's going to be 1. But what's interesting is that, well, let's make it 2. And actually, we're gonna realize this tensor. So when I do a times a times a, it's 8. But notice that it's only calling one kernel here, right? So in PyTorch, what would happen as soon as you did a times a, it would dispatch the kernel. But in tinygrad, it's lazy. So you can do 3 and they'll be fused into one kernel. I can even go further with this. I can do a .relu, right? Now, of course, .relu on 8s is just going to be 8, but maybe let's do like sine, right? So that's the sine of 8. And you see that that's all still one kernel. So if we increase the debug level, now I got to fix this because right now we have to restart in order to increase the debug level. If we increase the debug level, we can actually see the program that's being generated. So this is the OpenCL code. You see we multiply value, multiply ALU, and then do the sine. Well, that's all in one kernel. It's lazy by default, yeah. In theory, what I really want to move to is like something that looks more like how like a processor works. Right now, it'll lazy back forever, but I don't actually want it to lazy back forever. I want like once things are kind of once the back stuff's solidified, it should actually enqueue them. And this will help with speed. Okay, we got to fix the debug problem. Should I just make it a function? I like. Is there no way in Python to do this? Debug class. Property on global variable Python. If it's an object or dict, it doesn't copy the value. Yeah, but see, okay, I need like less than or equal 3 to work. Actually, yeah, I could just create a class, can't I? So if I make a class called like debug, and then I define a method on it. Something like this. It's not what I wanted to do. Oh, I mean, that's cute. Okay, here, I like this, Okay, so I can do from tinygrad.helpers import debug. And then you're saying in order to set it, I'll just do something like debug sub 2. Okay, int object is not callable. Yeah, okay, so I want self.value, so greater than, I'm asking the question, self.value greater than x. greater than or equal to. So I need a greater than or equal to method. And then I need an equals method. Yeah, I can add auto reload, you're right. I don't know, I don't actually trust auto reload. I'll do it though. I don't usually use this in I don't usually use this in VS Code. I'm pretty new to this. Greater than or equal to not supported between instances. Oh, it's just GE, right? Cool, that works. And now I should be able to say something like debug 2. It didn't work. Oh, can I do this? Does this work? I don't know if I can put a property decorator on call. Actually, let's just, before we try to run all the tinygrad stuff, what if I just, does this work? No, you can't put call on property. No. Yeah, I don't want to do debug.debug level. I want to keep all the existing code intact. I don't know. I actually don't think this is that bad. You can't put property on call. Oh, what if I do like repr? Oh, that's a string. Ugh, by the way, I hate autocomplete. Let's look at the Python magic methods. No, that's not what I want. Okay. Not supported between instances of debug, singleton, and int. Oh, but what if I do that? No. If I do that, it should work. Yeah, that works, but it's not what I want. No, I know that's for the int method. Yay. I was hoping it would implicitly do it. Oh, there's no... Interesting, there's no GT. Is there not? Oh, there is. I don't know why it's not listed there. It's a bad list. Okay. Use new and make it act like an int. No, that doesn't work if I return an int. It's not that bad to have those properties. Whoa. I can inherit int? Okay. I don't think so. I don't think int's a class. I don't think that's allowed. Wait, did that just work? Hang on. So what value does it have? 0. Okay. Inherit from int. Python. Int is immutable, so you can't modify it after it's created. No, see, that doesn't work. No, it's not a bad idea. It's interesting. I mean, those are the only ones I should ever really use anyway. There's no reason you'd ever check if debug is, oh, here, if not debug. What does not call? I guess it calls bool. What if I make a class property, then assign it the variable debug? I don't think so. That's probably just going to get called on the import. I don't know. I mean, this works. This is fine. Like, this is not even a big deal. Those are. I just wonder, is there like an easier way to write that? Is there like a quicker way to write that? It's a lot of lines. The 1,000 lines is more of a guideline. Yeah, I think, okay, that should be fine. It's just, it's the only way I see it used, right? Less than or equal to is extremely common. I don't actually need greater than. And I don't actually need equal to. Good, it enforces how you use the thing anyway. Like you should only be using greater than or equal to, or you can use not. Actually, I don't even think you should use not. This should just be if debug. No, not's fine. the only way you should ever use it is greater than or equal to. Cool. Now I can like debug 4. Wait, that didn't work. Why didn't that show me the code? That showed me the code. Okay, now what if I change it to debug 2? Okay, that didn't. What if I change it to 4? The code doesn't come back. Oh, probably because that's only going to happen the first time? No. Okay, when I create the AST runner, and the AST runner is not created the second time. Okay, so what if I change it to 11? Yeah, okay, that works. Okay, cool. Yeah, it's not going to... It'll only print that if it... Yeah, okay, that's fine. It only prints that on the first time. Okay, cool. Oh, I love this new debug behavior. It's so nice. Pretty clean, right? I don't know why I have to use the mouse for that. Okay. All right. Now that that's done, yeah, it'll just enforce, and then like if it's used in a different way anywhere, because it's all used as greater than or equal. You can look over here and you can see that, and it's used as not. So we support that, or we actually just probably shouldn't support not. It's okay, not's fine. I don't know waffle on this. Yeah, I know. Debug is so good and better than Torch. Thank you. Thank you. I worked really hard on debug. No. No. Okay. Cool. I don't know why this actually calls two kernels. I don't know. Let's look at it with debug equals 4. What are the two kernels? Okay, it's assigning 1, and then it's multiplying it by 2. Why are those things getting fused? I do force a contiguous in the 1s, and we may be able to get rid of that. Yeah, I don't know. The logging modules confuse me. Someone might give me a good case for them someday, but until then, I'm not sold. Okay. So now we can look at it, and there's a bunch of 2s. Great. I don't exactly understand why that's making 2 kernels. And we do force a contiguous in the 1s. Here. That's probably good. I mean, it's about where these things are commonly used. Okay. Now we can see, yep, we can print a times 4, 2a times 5. Now times 5. You see that has to create a new kernel. You see this n3? That means it created a new kernel. N4. But if I run it again, it's going to call that same n4 kernel. Cool. All right. What what else do you guys want to see? Let's do some matrices. So let's make B Tensor.eye 10. We'll get rid of the realizes here. We don't actually need to realize them. Warning, creating new view with reshape. Let's take a look at B. So I do all sorts of tricks to make I work. You see, I is actually 2 views, but it's not a big deal. So we can do like a matmul B to numpy. Debug force a lot. And of course, when you multiply by the identity matrix, you don't get anything special. So this is the creation of tensor A, this is the creation of tensor B, and then this is the multiplication. If we go look at how I is actually implemented, exactly understand why it has to create it and why those aren't fused. I'm cautious about fusing those kind of things, but it's mostly fine. Okay, cool. So that's matrix multiply with a thing times the identity. Maybe you guys want to see llama. So we can go in here, examples, llama. We can put in a prompt. I like chicken. I like, and then we'll do count as like 20. We can throw a jit on there, make it fast. All right, we're going to load the llama weights in. It's 5 gigabytes per second. I like chicken. I like it fried. I like it grilled. I like it baked. I like it cho. All right, cool. So a cool thing is we can use all those same debug options on llama. There we go. And this is just all the kernels running. Purple means that they're being jitted. So you can see for each of the things, we are getting a flops, a gigabytes per second. If we want it to go a little faster, we can throw OPTLOCAL on here. So you see we're getting 268 gigabytes per second. So large language models are limited in speed by memory. So this card has a theoretical memory bandwidth of 960. So we're getting 28% of the theoretical maximum on this card. So you see it's yeah. Can you quantize? No, I didn't support that. So a few things about the quantization. I don't like the int4 stuff at all. I think the int4 stuff's actually broken and no one's really tested it. The int8 stuff's fine. And if you want to write this, feel free. Contribute to tinygrad. So what else is like a good thing to show off? So I mean, we have like everything from tinygrad.nn import conv2d. So we can do like convolutions if you want them. Oh, we have stable diffusion also. Let's see if we can make stable diffusion work. Prompt, a cat in a hat. And then let's put steps up to 20 so it'll actually render something decent. Gotta load stable diffusion. Stable diffusion's a little slow. There's a $10,000 bounty if you can make stable diffusion on the M1 faster than any of the existing implementations. So there's a reason it's $10,000. It's going to require some serious work, but it's doable in under a month. So if you're cool with 10 grand for a month of work, why is this invoker cache complaining? I don't understand. Sounds like L3 at Fang. That's true. Except, you know what? You're never going to have to hear about HR, about diversity, about whatever shit they want to shove down your throat at Fang. You're never going to hear about being a team player. You're just going to code, man. It's chill. All right, so let's SCP it here. A cat in a hat. Do bounties get taxed? Yes. For over $600, I have to send you a 1099. I believe that's the law. IRS, don't fuck with me. I try my best. Yeah, my boy. And this is all so you can read this code. This is a clean re-implementation of stable diffusion. So we have stable diffusion here. It's 700 lines. And we have llama here. It's 420 lines. 420. What do I think about unit tests? I think unit tests are stupid, and nobody should ever. You haven't read tinygrad? I have so many tests. I think there's more lines of tests in tinygrad than there are in than there is other stuff, which is probably right. So we have tests for all the different backends. Check out these run ONNX tests. I'm not logged in. We have to sign into view logs. But check out these run ONNX tests. Well, actually, I can run them for you. So torch equals 1. Torch equals 1 uses the torch backend. The GPU backend is faster than torch backend, but the torch backend is interpreted and doesn't require compiling. So it's faster to actually run things with it if you're doing a lot of different things. And the CPU backend is NumPy, and NumPy is kind of trash. We got to call it to Fortran. Okay. So this is called test external test ONNX. And we can run it. Okay, cool. So there you go. 86 failures. 271 errors. I think if we run it with pytest, we can see a little bit more. So this is a good place to get started. Some of these test failures are one-line fixes. And if you want to contribute to tinygrad, this is a great way to get started. What is the direct ML pipeline? We'll Google that. None of these things are like really going to be good. V6 is nice, right? Thank you. The problem is they all, okay, so it comes down to complexity management. The people who write PyTorch, okay, so like, look, I start comma, and the people who make self-driving cars were mostly like dumb. They were actually dumb. I could not believe how dumb they were. And like, look, they all started failing companies that wasted millions of dollars. Cool. And then like, you know, people talk, oh, the Waymo and Cruise are driving around. Yeah, let me tell you about a company, guys. Let me tell you about a company. Here's a real company idea, okay? All right, I'm going to write it up. I'll write it up in Vim, all right? Okay, it's called the Revenue Company, okay? Let me explain how the Revenue Company works, okay? We sell dollars for 99 cents, okay? So you can come to us and you can buy, let's say you want to buy $100, right? So you can buy $100 for $99, right? And you can actually then, you know, you can take the $100 you buy and then you can, you know, use that to buy more money, right? So our revenue is very high. Actually, we have we only have a 1%, 1% off from being profitable, which is actually a lot better than Waymo and Cruise. Waymo and Cruise are way further than 1% off from being profitable. So look, we're going to get tons of revenue, right? Because who's not going to want to, all right, so let's say we raise $10 million, right? Remember, our cost of revenue is only 1% of that. So we're actually going to have 10 million times, that's going to be $1 billion in revenue, right? Now, you ask the question, unfortunately, this company's not profitable. We have a plan to become profitable, we will raise the dollar price to $1.01, right? We'll just raise the price a little bit, and then we'll be immensely, we'll be a very profitable company. Now, of course, first we have to focus on, growth, right? First we have to focus on growing this company, right? So unfortunately, it's not going to be quite $1 billion in revenue because we have to put some money into advertising to get the word out there for the revenue company, to tell people what a good deal this is, right? We sell dollars for 99 cents, right? And like, what VC would not back this company, right? This company is going to have hyper growth. There's actually no limit to the amount this company can scale. The only limiting factor on scaling this company is investment, right? So, I mean, why would you not want to invest in the revenue company, right? Think about it. The only limiting factor to growth of the revenue company is getting more investment because, you know, we do have a cost of goods sold. It does cost us $1 to sell our 99-cent goods. So we do lose a little bit of money, but that's okay because we're eventually going to raise the price and we're going to become profitable, right? So does the revenue company make sense to you guys? Does this seem like a brilliant idea, right? Okay, so hopefully you all think the revenue company is brilliant and you all want to invest, but hopefully you can apply the lessons learned from the revenue company to why Waymo and Cruise are not good businesses. Okay. It's a bank. I don't even know, but this company makes a lot of revenue. It's a great company and you should invest. Okay. Cool. Oh, we definitely need a referral scheme. How did I not think of that? Oh man. Oh, that's right. We got to raise the revenue. Okay. So unlike in the self-driving car space where I was competing against idiots, the people who write machine learning frameworks are actually quite smart. The PyTorch people are very smart. Most of the people who work at Meta are very smart. And the self-driving car people, it's not that like every individual who works at Waymo and Cruise is dumb. It's that the whole idea is just dumb, right? Like it's like nobody thought it through beyond, you know, never mind. Yeah, you know who sells dollars for 99 cents? The Fed. That's right. I mean, you like the revenue company, right? It's a good company. Now, look, think about it. What if you have to pick up your dollars later? What if we had a delay between when you give us the 99 cents and when you can pick up your dollar, right? Like it's like shipping, right? Think about it. You work at Meta, not smart. Look, PyTorch seems like there's pretty smart people leading PyTorch. But the problem is they're not managing complexity how tinygrad manages complexity. One way to write a machine learning framework, and you see almost all the machine learning frameworks doing this, is to just implement every op. But you don't want to do this because there's lots and lots and lots of ops. So for example, I wrote conv transpose in tinygrad yesterday. This is conv transpose 2D. It just calls into conv. Now, you'd never actually do this in PyTorch because this flip here, these permutes and flips, would cost you, you'd have to make copies. But in tinygrad, you don't have to make copies. In tinygrad, this goes all the way through. And in fact, the conv is not even a native op. This pool, which you go down to pool, this is all just memory ops, all just movement ops, which are zero cost in tinygrad because of the shape tracker. By the way, we did write up a nice tutorial here. I'm sitting here in tutorial and realizing there's not really anything better than like what I already wrote up in abstractions. So yeah, you can look at what the convolution actually is, and all the convolution actually is a multiply and then a sum. You reshape the input tensor and the weight tensor to exactly the right shape, multiply them together, and then sum So yeah, the tinycorp is very different from the self-driving car space in that we are competing actually against smart people with good ideas. But I think where we can win is in developer experience. And not developer experience using the thing, okay? So it's very easy to use pytorch, right? It's very easy to use JAX, it's easy to use TensorFlow. But it's really hard to develop on those libraries. The slowness has nothing to do with Python. We're launching on accelerators, so there's nothing slow. Tinygrad has a jit. You can use the jit, and then like all the jit really is here. You can see the jit calls are actually well, first we got to replace the inputs. This is the jit calls here. So you see that we just call the actual raw CL kernels, and you can replace this with CUDA graph. You can replace this with need. You can replace this with anything. Like if you're spending milliseconds on your GPU, the Python overhead doesn't matter when you're using the JIT. When you're not using the JIT, the Python overhead matters. There's a guy working on making it faster. $500 bounty locked to him for making the llama Python code without the JIT under 100 milliseconds. I don't know what else to show off in a tutorial, right? This isn't really like Triton. I think Triton has really nice tutorials. Well, I'll show you guys a convolution. So conv is the same. We can do let's do like a 1 to 16 with a 3x3 kernel called C. Let's create a random tensor. Say make it like ImageNet sized. No, we'll make it a bit smaller, 64 by 64. So I can do C sub image. Okay. Now we actually want to realize that. First, we're going to create the two things. This creates the weight. This creates the bias. And then that's the image. That's the convolution. So these are global dimensions. And you can see why this is the global dimension, right? So the output size is 16 and 64 by 64. So it's not padded. So we have 62 by 62 is the output. This 4 is, so you see that there's also a 4 here. These two 4s together make 16. This 4 means that it's, you can better see it in the code. This is the code that's actually generated for that convolution. This different steps that it goes through. So this is the output of what's called the linearizer. The linearizer takes, so these are the buffers that are going into the convolution. This is the image, this is the weights, this is the biases, and this is the output. So these views are the whole trick. Like the convolution is just basically looking at the input and output shape in a good way. This is actually a good example. So this is the so we load the image, we load the weights, multiply, accumulate. This is where we add the bias at the end, and then we store the output. So that 4 that I was talking about, this 4 here, this 4 comes from the fact that there's 4 stores at the end here. It means that each kernel is computing 4 at once. This 3 means that we've done a reduce on the loop, 3 wide. So you see that each one of these, this is actually 3 fetches. So the inner loop is just unrolled. And then this is a 4 and this is a 3. These are the reduced dimensions. Red is reduce, purple is unrolled, and yellow is the output. So that's the code that's actually generated. See that it summarizes that shape pretty nicely, and that's how long it takes. Okay, so now like I can do something like say padding equals 1 on the conv. So this is a padded convolution. You see that there's a bit of complexity added here now. So these have to check for the validity of each thing. Smurf0, thank you for gifting subs. You'll see that it also decides to unroll 2 dimensions now because 64 is a multiple of 4. So this means that the output size is a 4x4 chunk, and it's capable of using float 4 for all those things, all the ALU ops, and yeah, 400 gigaflops for a very tiny convolution. We can make the convolution have stride. You want stride? We can do stride. You see that the output size changes. And this is just how the optimizer decides to do it. So right now the optimizer is a set of hard-coded rules in linearizer. I wrote these rules to make the OpenPilot convolutions fast. So this is it's called hand-coded optimizations. But eventually we can replace this, and we'll replace it pretty soon with search and like really smart ML search. Okay, we'll disable subscriber-only chat, and we'll take tinygrad related questions. For Mojo, I will talk about Mojo once it's open source. While it's not open source, it's just not that interesting. I can make anything fast if the server is hidden. We don't have an einops-style API. I'm very interested in that. I put a $200 bounty on finishing this up. So in order to do einops, you have to have 0-dimensional tensors. So like when I do something like, if I do like tensor sub 6, you can't create a tensor from 6. I have to do an array. And this has a dimension of 1. But I want to support tensors that are just like this, and then they're tensors without shape. They're tensors with 0-dimensional shape. Yo, I love when the haters start talking about the cardinality of infinity. By the way, guys, just so you know, the cardinality of the real numbers and the cardinality of the integers is the same, and like anyone who thinks differently is a math. And you know, it's just like, where are these numbers, man? Oh, but there's like there's uncountable infinity real numbers. Yeah, you know what? All the integer sentences are countable. All the English sentences, every sentence is countable, right? Every computer program is countable. So you're telling me that there's these numbers out there that not only is it not a computer program that can compute them, and that's fine. You have numbers like Chaitin's constant. That's a number. That's great because there's a word for it, Chaitin's constant. You have all these numbers that are undescribable, right? Because all the descriptions can be put in a one-to-one correspondence with the integers. So you're telling me that there's an uncountable infinity of, you know what? How did you get me derailed on this? How did you get me derailed on this? The rationals are countable and dense in the reals. Well, the rationals are countable. I don't even think that's controversial. Are they dense in the reals? That one I don't know about. I'll have to think more about that. I do not believe that the real numbers are recursively enumerable. There exists infinite reals between 0 and 1. Yes, I know, but there also exists infinite numbers greater than 1,000, right? Like, yes, I evolve here. Who's here? Your juice is here. Okay. The axiom of choice is a lie pushed by big math. Absolutely. I mean, no, you shouldn't even need an axiom of choice because uncountable infinities aren't real. And nobody doubts that you can choose stuff from countable sets. How did you guys derail me? Hi, guys. I'm a constructivist. I'm open-minded on the law of the excluded middle and whether you can use it or not. Okay, so that's a convolution. Oh, the other thing I like to show off is my matrix multiply. Insert cell above. Insert cell above. Shift. Cool. That was cool. I like that. That's a nice shortcut key. How do you become good at coding, bro? You play COD a lot. Okay. So let's make some tensors. Now, if we want to multiply them, we can do that, and that just works. But there's another way to do that. And I want you to think about a cube, right? So here's a cube. The complexity of matrix multiplication is n cubed because it's a cube, right? So I can take my two tensors, my a and my b, right? And then I have like c equals a at b, right? So this is a and this is b. C is like the top face of the cube, right? So what we're going to do with a and b is we're going to align these two dimensions on this cube. We're going to expand them, and then we're going to multiply them, and then we're going to sum them, right? So let's actually write that code. So if we want to align them, a.reshape, I think it's this. B, we have to permute. And we can say AA times BB dot sum axis equals 2. Well, that's CC. All right, and now NP dot testing dot assert all close c dot numpy cc dot numpy. Didn't work. I think I have to flip these. There we go. So this is equivalent to this. And they're the same speed. They're both getting about 6 teraflops. Okay, want me to do something else? Okay, so we'll make the inner dimension 512. So if we want the inner dimension to be 512, then the output matrix should be, there you go. Notice how it had to recompile it. But notice how it only had to compile it once, because the kernel generated for that is equivalent to the kernel generated for that. We can look at what's actually generated here. So this is the matrix multiply. It's a 4x4 output space. We've also unrolled it 4 times, so it's using floats. This is the generated code. And that's the thing. It's 256 by 256 because those two are turning into 4s. 128 times 4 is 512, and that's what this 512 is. So like these dimensions, these are a dimension, and these are a dimension. The kernel logs are beautiful. This is how tinygrad's going to win hearts and minds. this. I worked so hard on these colors. Yeah, and it really like shows you what things are doing. So like, okay, let's take a tinygrad example. So this one here runs ImageNet. It runs an EfficientNet 0, and you'll see that it like, so it outputs hen there. These are the really old tinygrad examples, but we've kept them all working. So you see it looks at this and it's like, oh, it's got a hen. Okay, cool. Actually, let's put it, remember that cat picture we generated before? Let's run it on that. Oh, it's a cowboy hat. Well, it is a cat and a hat. That's true. It focused on the hat, not the cat. Let's try a bigger EfficientNet and see if it still thinks it's a hat, or it starts to look at the cat. If you don't remember the picture from before, it's this. Oh, see, now it thinks it's okay. So if I do num4, it focuses on the cat. If I do num0, it focuses on the hat. Num0 is the default, which just means it loads an EfficientNet 0. But those are both obviously accurate answers. And we can use debug equal to, and we can look at all the kernels that are actually running to make that a possibility. Let me throw some OPTLOCAL on there so we can actually try to get some speed out of this thing. This is a tiny ImageNet, so you're not really going to get a lot of speed. But you see that the time spent on the GPU is only 1.84 milliseconds, which is really good. And then those are all the kernels that are running. Yeah, so .realize is going to like end all the laziness. It's not actually going to like CL finish. It's only going to enqueue the stuff on the GPU queue. So we're going to take a look at it with num4, and you're going to see it's going to use a bunch more kernels. So it's 226 kernels to run a num4. We actually have tests for the amount of kernels, and if you see that these are all R's, if they're all R's, it's doing a good job of diffusion. So R's are reduced kernels, and E's are element-wise kernels. So element-wise kernels means that the inputs and the outputs have the same dimension, and R's mean it's a reduced, so it shrinks it. Yeah, so we're getting some decent. And all these speeds are pretty terrible, but still, 5 milliseconds for B4, you're not going to be upset with that. Of course, it's actually slower than that because it's spending a lot of time compiling, but you can put this in a JIT and then it's really fast. Which just like, because it runs the same thing every time. Okay. Any more tinygrad questions? I'm here to answer your questions. I'm here to be friendly to noobs. I'm not going to spaz out on self-driving car companies. I'm not gonna go off into the weeds about infinities. I'm here to focus and deliver good quality noob content to you, the viewer. Because really, it's all about you. It's all about you, the viewer. Without you, the viewer, I'd just be a guy in my room talking to myself. But when I'm a guy talking to myself with 500 people on the internet watching, this is more socially acceptable. What's the tiny ML scene? It's like do I like wear like goth clothes or something? What are your plans for the future with tinygrad? Well, I'm going to delete the repo and then I'm going to move to a cave in Cambodia. We have autotune stuff. The thing about autotune is like it's just slow. It's just slow to run. OPTLOCAL is some autotune. It actually does make it faster. This is an autotuner. Autotune's like the last thing we'll write. I also don't want to write a stupid autotune. I want to write an ML-based autotune. But first, like, complete the whole stack abstraction. No, I didn't cancel my Netflix. I watched Selling Sunset. You guys ever watch Selling Sunset? So like the real transformer, what was Paris the first person to claim a bounty? From the Tiny Corp, by the way. A bounty for the RNNT model. And now they're working on the MLPerf BERT model. So yeah, BERT is a transformer. I think the model is actually pretty simple. Does it use it? The problem is you always end up just rewriting attention. Like here, look, it's rewritten attention always. There's so many implementations of attention. It's because they all differ a tiny bit. Oh, I love below deck too. How do I add it to Hugging Face? I don't know how to do that. I love Hugging Face. How do I add tinygrad? Yeah, it's possible to get the same perf with a few ops. If you want to contribute to tinygrad, you should join the Discord. Those ONNX tests that I showed off are a great thing to just start fixing. You should be able to have like a pull request up in 15 minutes that fixes one of them. How much of the AMD driver stack do I need? So I still need the kernel piece. The user space becomes very, very simple if I don't use that. Unfortunately, the kernel driver is buggy. I'm emailing someone with AMD asking for docs. Intel has these incredible docs. I'm actually going to show them off. Because this is my AMD. Look, I like you, but you know, I found something even more well documented than your chip, and it's the Intel chip. So you know, there's some chance we're gonna call an audible and switch to Intel. GGML is targeting kind of a different audience. It's a lot of hand-coded stuff to make things fast on a certain architecture, the M1, which is cool. No, like Intel has, these are their registers. Like you can get their registers from their GPU. This is awesome. And then also, they're so cheap. They're three. Look at this. Look at this. $329, and it has the same. I learned yesterday that they have this thing called the XMX. Let's see if we can find it here. Call it something else. I mean, you have to hand it to Intel. There's a lot of docs. That doesn't mean you can easily find anything in all these docs. But it's fully documented. All their registers are fully documented. Oh, that's not the 16 gig one. I bought, yeah, here. This one. I got one of these on eBay for $330 with 16 gigs. And apparently they have more FP16 flops. So it's like they have like 40 FP32 flops, 40 teraflops. No, it's not 40. They have like 20, but it's 8-to-1 for their matrix multiply. So there's actually more teraflops of FP16 on this $349 graphics card than there is on the 7900 XTX. So look, I like AMD, and if they, but the driver's so bad. So okay, this is my prototype computer down here. Let me make sure you guys can actually see it well. See it? This is my prototype tinybox down here. Don't worry, the tinybox will look a lot nicer than this. I can't put 2 cards in it. When I try to put 2 graphics cards in it, it crashes. Like, check it out. This one's still in the bag. Cause I can't put it in because the driver crashes. And like, do I really want to track this garbage down? Like, not really. So I bought one of these. Oh, I don't doubt Xilinx software's worse. This isn't Xilinx, it's AMD. It's Intel, man. I bought one of these cards. We'll try it. I might totally hate it. But I do see a 20% world in which we call an audible and just go all in on Intel. Intel. What's Q Laura? I heard people mention this. Oh, but this is fine-tuned stuff. It's not training from scratch. Oh, by the way, there's like a new champion someone mentioned. There's like someone released like a 40 billion model that's better than 65 billion llama. The probability I will switch to NVIDIA is 0 because one of the goals of the Tiny Corp is fucking NVIDIA. Falcon 40B, yeah, that's it. Apache 2. Is there any difference between this and Apache 2? With a series of modifications, commercially exploiting to make royalty payments. I mean, it's more open than Llama. Oh, you have to pay if you profit. I'm not opposed to that. $500 tokens per second. Well, 500 tokens per second isn't possible. So the basic way to compute how many tokens per second is possible is to take your memory bandwidth. So the memory bandwidth of this card is 960 and divide it by the number of weights times the size of the weight. So let's say we're doing llama int 8 on a single llama 7b int 8 on a single 7900 XTX. The maximum tokens we could get is 137 tokens per second. Do I feel like I'm doing AMD's work? Look, like, I'm not really that worried about that, right? Like I see the people on Twitter, George is asking for people to do free work, blah, 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 blah. No, I'm asking you to, if you want, write open source code, right? I'm not doing free work, I'm writing open source code. How I choose to direct my efforts is my choice. Yeah, you know, I hope I do hope AMD does support me with a bit more documentation. Ideally makes more documentation open. So AMD does have great documentation on their instruction set. The RDNA 3 PDF, this is awesome, but it doesn't go into like the memory architecture of the GPU. It doesn't go into how the scheduler works. It doesn't talk about how like the copy engine works. But yeah, no, it's pretty cool. So actually, check out this document. This document's well written too. It's much better written than the Intel stuff. Why isn't AMD doing it already? Well, what AMD looks like they do is they take every NVIDIA thing and they just make a clone version of it. And I don't think this is smart. I think if you do this, you're always going to be playing catch up. I don't know. Maybe it's what their customers want, but like they have something called, what is it? Compute tile AMD kernel. I don't remember what it was. But they just basically look like for each NVIDIA thing, they're like, okay, write an AMD version of it. Composable kernel, that's it. So composable kernel is basically a clone. I looked more into it. It's a clone of Cutlass. And like, okay, it's not necessarily a bad idea, but like if you want to leapfrog NVIDIA, you can't do it by so for consumer hardware without a GPU, language models are in this interesting place where you don't actually need that many flops. All you need is memory bandwidth. So what are you talking about? What consumer hardware do you have? If you have a basic M1, you can get 7 tokens per second and then if you get it down to 4-bit, you can get 14. Yeah, just take your memory bandwidth in gigabytes per second, divide it by your model parameters in billions, and then multiply it by however whatever your D type is, because that's bytes. So if it's a byte, you multiply it by 1. So one of the specs I'm most happy about with the tinybox is this. It has 5.76 terabytes per second of RAM bandwidth. And this is a pretty hard spec to compete with. So this has more RAM bandwidth than an H100. Remember, an H100 is the price of 2 tiny boxes. And this is going to be your limiting factor on. So, if you want to figure out, let's say you wanted to run 40B Falcon, and I assume it's in, yeah, so there's about 80 gigs of weights here, so I assume it's FP16. So we're going to do 40 times 2, and we should be able to get 72 tokens per second on Falcon 40B on a tinybox. In practice, probably about half that. What would I use instead of AMD EPYC? AMD EPYC has a lot of PCIe lines and it's cheap. I don't care about the memory channels. I care about PCIe lines. Novel LLMs. One of these days, should we do a stream? Everyone likes talking about this. I don't actually know if it's any good. But I know there's hype around these things. So we should probably write a tinygrad port of them. Why don't you like Infinity Fabric? You mean the way that they connect? This is how they connect their little, their chiplets. But yeah, that was basically it for today's stream. I just wanted to show off a few tinygrad things. And have some noobs be able to get into it. You guys saw what I wanted. I made my change that I wanted for debug. Can I write about nerf? I don't care that much about it. I've looked into that. I don't care that much about that. This one's kind of interesting. And I'm like, I want to implement this to really understand what it is. Can I talk about how backends are implemented in tinygrad? Yes. So these are the backends here in runtime. So they're very short. This is the complete torch backend. This is the complete NumPy backend. GPU backend, a little bit longer. So these backends are like, I call them runtimes. They're actually what will run it on the device. The interpreted ones, all you need is a runtime. For the compiled ones, we also have code gen. So this is the code gen for LLVM. This is the code gen for, I call it C style, but it's like OpenCL, Clang, CUDA, Metal. And then this is the linearizer, which converts ASTs, which are trees, into lines, which can be turned into assembly. Why isn't verification working in the tinygrad Discord? I have no idea. I'm probably a Discord problem. And then how does the JIT work? Okay, so the JIT, you can just decorate things with tinyJIT. tinyJIT just captures, remember how we have these kernels? So we can do an example with the JIT. Let's do an example with the JIT. Okay, so let's create a 10, let's create a few 10 tensors, right? So let's say we want to do something like A plus B dot mean. So we'll add the mean of B to A, right? So now how many kernels is this going to be? Let's make ones. So yeah, this is actually just 2 kernels. These are creations kernels. Well, let's not do ones. Let's do random. Okay, so there's 2 kernels here. This is the mean kernel, and this is the add kernel. Because first we have to compute the mean of B. You can see the output size is 1, and then we have to do the add, right? So we can look at what this actually is, and of course it's random garbage because I used random. Now let's say I want to JIT this, right? So let's put this in a function. Right now, it has to look at A and B and all that stuff, and actually A and B are inputs, so let's put A and B as inputs, right? Right now it has to look at this, it has to run this code every time it calls function, right? It has to look, okay, what's a mean? How do I do that? Okay, fetch that kernel, blah, 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 blah. Or you can just from tinygrad.jit import tinyjit, and then I can decorate this with tinyjit. Now it does the same thing the first time, does the same thing the second time, but on the third time, you see that the JIT captured 2 kernels with 2 inputs. Because there's 2 kernels inside of here, so it captured 2 kernels, and you can see now they're purple. And now, yeah, we can actually look at, cancel. No, don't do that. Man, okay, insert cell, insert so this code cell above. Okay, so we can look inside here and we can see what's actually cached. And you'll see that these are like AST runners. This is a list of all the functions. Can you see the compiled code? Yeah, so if we look at one of them, I think I can do dot, let's get the actual runner, and no, it's not that code. Let's look at an AST runner. Dot proc. There you go, there's a code. So this is the code for the first thing, which you can see is just a reduce. It's a mean of a thing with 10, so it just loads them all, adds them all up, multiplies it by 0.1, and then outputs it. Now we can look at the second one as well. And the second one as well is just a kernel to add them together. It just reads that and it's broadcasted. There you go. This is good. PyTorch is too chunky. Thank you. What else we got? Oh, good. I'm glad I showed off the JIT. That was pretty nice. You just got apple juice? What? Should I take a picture of it and complain?
No, it's just it says it's green juice, but the main ingredient is actually apple.
What, apples aren't green? What about green apples? Do you think they used red apples in your green juice?
They're not greens, they're not leaves.
Oh, you want leaves?
I wanted leaves and I got fruit.
Oh, you wanted leaves and you got fruit. You know what that was me. Sorry. Oh, Pam. Doxed? Where'd I get doxed, bro? Did I live in San Diego? Yeah, I live in San Diego, bros.
I think you're like undoxable, George.
What do you mean undoxable?
Like all her information.
No, you could dock me, but if you show up at my house and try to come in, I'll shoot you in the fucking face. Like, that's the real truth. Castle doctrine, boys. Castle doctrine. I'm uppity today. That's how you do it in America. You don't come in my house, bro. People think no one's got guns in California. I don't know why you think that. This isn't San Francisco, man. No, that's why, like, you know. All right. Now we're getting real derailed. What else we got? Subscriber only. Do any subscribers have any more questions for tinygrad? I appreciate who asked the JIT question. $691 people. Oh, transferring kernels to device. Oh, here I can show you what that looks like. Shift this, enter. Oh no, I gotta be in like. There we go. Matters where I click. Okay. So let's make a tensor, big tensor. Let's say something like, okay, so how big is this tensor? Right? How big is that? Well, so it's 16 million things times 4, so it's 64 megabytes, okay? So we can send it to CPU. This converts it to CPU. We have to realize that we actually want it to go to the CPU. CPU to NumPy is free. And we can put it back on the GPU if we want, but then it's got to copy it back again. Do I have any debugging around copies? I'm not sure I do. I should add some debugging around copies. Probably want to add it here. do I not use debug in here? I don't use debug in here at all. I shouldn't be messing with this now. But we could just, there we go. It's kind of nice. So this is going to first copy it to the GPU, then it copies it to the CPU, then it copies it back to the GPU. How come? Oh, look at PyTorch tutorials, but make them simple and more tiny. That actually seems like a pretty smart idea. You want a link to a good PyTorch tutorial? This is why I don't like auto reload. I don't trust it. Okay. So you'll see that when I do things like Tensor.ones, this one's never actually copied anywhere. Oh, it still copies. It copies a single float to the GPU. I see. Should it actually do that? Oh, put that there. Because if it's constant folded, it shouldn't. It doesn't actually copy it. I'm getting rid of auto reload. I don't trust auto reload. It keeps breaking. What's fashion-emnist? What is fashion-emnist? Oh, they're fashion. You need ones that make people go wow like dcgan. How fast is this train? Should we try this? Should we do this tutorial? Run in collab? Yeah. All right, should we try dcgan? Does that sound fun? One of the PyTorch Lightning guys was very knowledgeable. All right, should we try dcgan? We need the celeb A dataset. That can't be it. Where do I get this file? Oh, it's huge. .image folder. Well, it's a pretty nice abstraction. That's pretty easy, bros. Oh, good thing I just implemented conv transpose 2D. I don't have an NN version of it, though. Oh, do I need an NN version of it? Should I just set an argument called transpose on here? That might be a more tinygrad way to do it. First, I should probably commit what I have. Let me commit my by the way, if you're going to commit to tinygrad, if you install the pre-commit hooks, I'll just look up how to install pre-commit hooks. You'll see that it does some nice stuff for you. Oh, everything changed. So we gotta really do the MyPy again. Wow, TANH. Leaky ReLUs. There's a lot of code, guys. Are we prepared for dcgan? I don't know if we're prepared. Oh, good. Please be in a Please be in a folder. It's very impolite, by the way, if you're making a zip file to not put it in a folder. Oh, good, they put it in a folder. Oh. Okay. Cool. Hope you like JPEG. You think it's going to train in no time? Well, we don't really have... I'm gonna just add transpose here. I don't know how I feel about that. Maybe... Is it size is the same? In channels, out channels, kernel size. Okay, it's all the same. Maybe this works. If it's just those two lines, fine, it can have it. Okay. So we're gonna make a generator. Something to note about tinygrad is we don't have, you don't need anything like NN module. So we also don't have any NN ReLU. Let's look at NGF. What's NGF? Size of feature maps in generator. Okay, cool. What's NZ? Size of Z latent vector. Okay, that's cool. Cool story, bro. And then NC is the number of channels in the training images. This is a nice tutorial. Let's link to it. Version of dcgan face tutorial. Okay. Now we don't have any NN ReLU stuff, so we can just say self.state equals this, and then instead of NN ReLU, you just write lambda x.relu. Or actually, you can do even better and just write tensor.relu. Right? And there's no reason you shouldn't be able to do tensor.relu, because remember, there's no state. What does pytorch call them? It calls it main for some reason. We'll call it master, just to fuck with them. Okay, we need a call function. X returns self.main x. Great. Okay, there's our generator in tinygrad. The tutorial only trains for 5 epochs? Okay, this is great. Okay, let's write a quick data loader. Well, actually, we need our discriminator first. Spell it right. Discriminator. Okay. NDF, we're gonna have to take from there. I like doing things like this one at a time. I don't just like massively copying stuff I don't understand. Cool. Okay, so leaky relu, I think we have that one. Yeah. But here we're not going to be able to write tensor leaky relu. We're going to have to use lambda. So we just say lambda x x dot leaky relu 0.2. Okay, in place is stupid. And then for this one, we can do tensor.sigmoid. Okay, cool. And actually, this is wrong. We actually want to do x dot sequential. Self-dominant. Okay. So you see the code is very similar to PyTorch. I actually think mine's a little bit simpler. Don't create classes that don't have state, but it creates all the classes for the ones that do have state. Hopefully my conv transpose is right. Really needs a test. Good, that runs. Okay. Deal with the wait-init later. Net G equals generator, net D equals discriminator. All right, we create them both. Now we need a batched loader. I wrote a decent one. I should just copy it, but I should really write these. Like, we should have this stuff just built into tinygrad. It is all very simple to write. It's just annoying to like copy it all the time. If we go in MLPerf model eval, I wrote this resnet. Here it is. This. Okay, cool. We just need to write it. We'll call it celeb A iterates. So we have import pathlib. We should have good examples here. I think Leroy Speech uses it here. dcgan pathlib file parent slash dataset slash align celeb A, and it's just in there. Okay. os.lister. Say path equals always improv things in Python. Path slash A. We want to load that image. Want to load images again. Image load. Pale import image. Pale import image. We'll throw this. I have a cross-process thing we can use too. Image equals that, and then blah 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 blah. Let's just print image. 4x and select iterate. Yes, I made the font bigger. I actually want people to follow along. Nice guy, right? I need another dot parent. All right, great. hell size image is that? How big are these images supposed to be? Image size. Oh. Wow, they're making them tiny. Okay. Let's do that. Oh, I have this ImageNet. Resize, center crop. I moved the normalization of ImageNet somewhere else. Great. Okay, now we want to batch them. I have all this code. I just need to like refactor this to like be nice. Pretty good, right? POSIX path has no attributes split. Oh, that's not right. How does this even work? Code doesn't even look right. Whatever. Now I have to write a trainer. So these are mostly the same. Wait, they changed the beta? I don't know how I feel about that. You just do nn.optim and tinygrad. It's not parameters, it's nn.optim.get parameters. Yeah, we'll just import optim. And then here for Adam, it's B1 equals beta 1. Cool. That's a crazy beta parameter. I've never seen that before. Okay, let's bring up a tinygrad training loop so we can look at it. Okay, so we don't zero the grad on the net, we zero the grad on the optimizer. So we can zero grad there. Train with all real batch. Oh, I didn't normalize it, did I? We'll deal with that later. Torch full B size. What's real label? That's just ones. That's just confusing. Okay. So we run this. Output equals netd this criterion. Where's criterion? This is our loss function. Okay, BCE loss. Do I have that? I don't think I do. I have like log softmax, but I don't have BCE loss. There's a GAN example. I wonder what they did for it. Loss real. That's all they did? Yeah, that's just dot mean. I don't know. Like, that doesn't really seem right. But yeah, I mean, I guess I could just do this. I don't think this mnscan is right. Yeah, I have some real doubts about this. Okay, let's write the right loss function. Okay, so what are y and x? So imagine x is the input and y is the real ground truth. So if y is, we just do log of x. So I think I just do dot log. All right, and then for the fake one, I'll do log 1 minus. Yeah. For the generated one. All right, that looks nicer, I think. Okay, where'd my pytorch tutorial go? We'll load it for the 17th time. This is what I mean, like you can hide so much things that are actually just like, it's just log, you know? All right, so we do backwards, now we do the fake batch, okay. Train with all fake batch. Okay, we have noise equals tensor.randn. That. I'm streaming. I lied about being done soon. But yes, I'd love to go to Moniker, but later. Oh, we have our batch size. Why is this not a parameter up here? Yeah, I see what they want me to do. We'll just do x.shape 0. Okay, we run that. Weird stuff. Just do that. Oh, we probably want to get our D. So I have no idea if any of this is going to work. I've tested training kind of very little. I've done mostly inference so far. So if this fails, you know, don't say tinygrad's terrible, guys. Don't. We love tinygrad. All right. And then we want to do a step. Look how much shorter my code is than the pytorch code. The difference is my code doesn't work. Okay. Optimizer g.0grad. I don't know what the view is, but discriminator on noise. use the real label here. So it's this. Error G. Okay, optimizer G step. Actually, just this. Print rdreal.numpy, rdfake.numpy, and rg.numpy. All right, cool. Does it work? Oh. Yeah. We have to normalize this too. So we'll just do something like fine. Cannot create tensor from this shit. Why not? Oh, well that shouldn't be a tensor. I don't need a tensor there. And what's x? That's not right. What did I do? It should be fake. And this is already a tensor, so we can get rid of that. Move this up to here. Input tensor shape does not match the shape of the weights. Where? When I'm trying to run net D image here. I'm trying to run a D. That's not even using weird stuff. NC is 3. Oh, it's just got to be permuted. I have all this in my. Now we're on to net G is a problem. Does not match the shape of the weights. 512 versus 100. Oh, this is because... Yeah. We gotta flip them. Oh no! It uses a stride. Well, that's tragic. The one thing I don't support. we should make this work. All right, let's debug a little. Is it running? There you go. All right, we're training something. It takes a while because it's got to compile it the first time. Tensor has no attributes CTX. What? Wow, that's a deep bug. Interesting. Yeah, let's see. Yeah, okay, so the problem, I think I have to do fake.detach. And I don't know why why didn't the pytorch one have to do that? T.grad is not none. Oh, what the hell? How is this supposed to work? Yeah, okay, this doesn't really work. Let's just try that. Okay, I think it's training. Let's see what kind of speed we're getting. How do you print the graph? Graph equals 1. Okay, it's training. Nan. Oh, I think I have to put the detach here, and then I don't have to do it. Oh, and where'd my zero grad go? Yeah, that stays there. I'm gonna put these both here. Shouldn't matter. And then here I put fake. I can also run that earlier. Okay, good. Now we're only running it once. This is stupid. I'm just gonna write error D. Yeah, why would I not? Error D equals error D real plus error D fake. Error D dot backwards. Optimizer D dot step. That's gone. Train discriminator. Train generator. Also, I'm going to get rid of these logs. I think they actually might have had the right idea in the other one. Because they should output logits, right? Oh, I do have stupid tan H's and sigmoids. I guess the only one that matters here is the sigmoid. Let's get rid of that sigmoid. Okay. Is it making pictures of celebrities? Do they know things? Let's find out. We should also throw this all in a JIT. The double backticks? Where do you see double backticks? Yeah, I know. It's a lot simpler than the torch tutorial. I just don't think it works yet. Let me add some timing stuff. I just copy and pasted this in the torch tutorial. I don't really know. I also don't know if my conv transpose 2D is right. I don't know if my iterator's right. I don't know if anything's right. But yeah, I mean, in theory, this should all work. Alex wants to go get coffee. Should we go get coffee with Alex? I don't know. I don't know if those like losses are terrible. Let's see what the pytorch one gives. Yeah, okay, so they have different numbers. Well, this kind of makes sense because they used a different... I didn't put the stupid... the tan-H is fine, but you don't need that sigmoid. Like, logits are fine. We should really test conv transpose 2D, which we did not. I'm also not sure that's actually normalizing it correctly, and it does matter, I think. Because, yeah, it does. Hang on. Let me think about this for a second. Yeah, it matters. Hang on. Because they're using tan-H. Alright, tan-H goes from 0 to 1, so that's right. Normalize. I don't know what any of that means. I did this in this one, though, and I struggled with this exact same thing, and I didn't document it. ImageNet, model eval, here. I have an idea that I might want to just divide it by 255. I don't know. Again, I don't really think that matters. Yeah, I think that's all the same. I don't know if that's going to change anything. But yeah, it'll keep me off the rails at least. The losses in GANs don't really mean anything. Okay, you want to look at an image? It's kind of annoying. I don't really know how to do that. Or we can put this in a notebook. Actually, there's cute ways to kind of just turn anything into a notebook. Maybe we'll try that. I do it in abstractions. Okay, let's just say imports and constants. Imports, constants, model definition, trainer. Let's run the cell. Oh, the name is main. Okay, good. Okay, let's im show x sub import im show. There we go. That's pretty good. You need the absolute right hyperparameters. There we go. Look at this one we generated. We're rich. No, let's actually generate one. Invalid shape? Oh, my strides are wrong. It's not even the right size, boys. Oh, we done goofed. Gotta make the fucking strides work. Oh, we did a bad job. We did a bad job. Look, it's wrong. Yeah. My new thing that I do when I'm overwhelmed, I just scream. Whoa, how is it so simple? Well, one, because it's using tinygrad, and two, because it doesn't work. You can make really simple code that doesn't work. Some people focus too much on making code work and not making it look beautiful. Bounty for strides? If you fix both strides and padding, but how quickly are you going to do it? That's the problem. No, that's like not worth a bounty. Like, it's... You know, yeah, the bounties are more kind of like, they're not like they gotta kind of be chill. Like, not everything's gonna get paid and get a bounty. If you're not doing this because it's fun, don't do it. You know, those strides are the wrong side. I commented out all that stride garbage and it's just wrong. This in theory is right. Like, there's probably like a 5-line change across tinygrad to make this thing work. And then just a lot of compute. I think we can make it faster with a JIT too. People get greedy for bounties. Yeah, if people are getting greedy, I'm getting rid of bounties, okay? Tell you can only have bounties if you're nice. You know, you want to have nice things. I'm doing -5. You think the normalization should be that? I'm not sure it should be, actually. I think what I did might be right. Okay. So it's taking 300 milliseconds a step. Let's see how much of that is actually spent on the GPU. Oh, I can also do, for a little help with that, I can do global counters.reset. Global counter is just like a cool library that like helps you track things. So now I can see like my time on the GPU. Okay, so it's spending 167 milliseconds on the GPU, and that is slow as balls. Let me do OPTLOCAL. Okay, the forward pass is fast. Now it's doing the backwards pass. Oh, look, we're getting 20 teraflops in some of these. That's pretty good. OPTLOCAL will only be slow the first time, too. It'll be real fast the next time. It saves it to a file. Yeah, this is kind of mediocre. Okay, so we're spending 92 milliseconds on the GPU. I think it'll be faster this time, too. Okay, 117 milliseconds on the GPU. Let's keep OPTLOCAL, get rid of debug. Let's see how fast it is. Debug slows it down too quite a bit because it has to do okay, 257. Now let's create a function called train step, pass in image and noise. Now we're going to pass in image and noise. Oh, do we want to return fake? I don't really care about that. We'll just do it, but it doesn't really matter. I don't have to return that. It should be free though. Okay. Now if you want, you can do from tinygrad.jit import tinyjet, and I can decorate this with tinyjet. See how much faster that makes things. There you go, that's pretty fast. It's also wasting time in this. We can put that in another process and then it'll be fast. Where's my eval? Model eval, cross process. data object is not callable. Yeah, because I called it. I don't call it. There you go. It's pretty fast. I have no idea if that's actually fast. How fast is torches? Training. All right, now how many bugs did I write? Probably a lot. And that gets us down mostly, I think, well, we can check the speed on the GPU with debug equals 2. So my actual time spent on the GPU is 100 milliseconds. Right? And they're purple, meaning they're all jitted. How many flops is it total? So we can see we're doing 174 gigaflops. So our average is 3 teraflops. It's pretty good, right? I don't know. I don't actually know if that's good. I have legitimately no idea. Oh no, that's just for that part. I guess there's a few more kernels too. Is that fast? By the way, this is training on an AMD card. I think it'd be faster on an NVIDIA card, but you know, we don't use NVIDIA, we use AMD here. Oh, I remember. I didn't fix the strides yet. Oh, I gotta fix the strides. Oh, I gotta fix the strides. This tutorial notebook, there's nothing good in here, is there? No, get rid of it. Did I push this branch? Let me push this branch because that's actually really good. And then we'll also check out dcgan. Do people like GANs? Are GANs going to impress people? Oh, let's get all the pictures of Sam Altman. Great. Data curation. Is that what we want to do on this stream? Yawn. It's running. Okay, well, this is just wrong. It's compiling. Auto setup remote. Yeah, I don't really like that. I don't mind doing that. Like, I always do this just so I can copy and paste it and don't have to think about it. But it's nice, like, it reminds me, it gives me like a warning. Okay, well, if one of your things is 64 by 64 and one of your things is... Why are these things just stupidly big? I guess that's what I don't understand. What it like means. Like, why are these things so big? The numbers are so big. How's my discriminator and my generator both doing this well? I don't know. The losses are meaningless in GANs. We just have to look at the pictures. Okay, guys. I'm going to make you a deal. Here's my deal. if somebody fixes strides, and it's pretty straightforward, there's already a test, it's just commented out, by tomorrow, I will stream and finish the dcgan tomorrow. If nobody fixes strides, then I will not finish the dcgan. Does that seem good? Yeah, okay, so the problem right now is, at least one problem right now, is that the output size from the generator is different from the output size from the discriminator, and it's because I'm not doing the chomping and strides right. So you can see like what I did here, and it's wrong. This is also kind of ugly. I really shouldn't be permuting the weights. I should create a different weight. It might just be, you might just want to copy and paste this. I don't know. Am I interested in adding more linear algebra? Basically, what I want is a test for conv transpose 2D in the NN. So add it to test NN. If you add it here, we have tests for conv 2D here. I want this, but for conv 2D transpose. You're lucky that I added the transpose. That was just yesterday. So I want that for, yeah, transpose, and I want to test it with strides. There is a test. I wrote the test, but here it's just commented out, not currently supported. So you'll comment that out, you'll fix up the strides. I think that my code is actually correct here. I think that the problem is just you have to shrink the output tensor. I used a large font size for you guys today. You know, look, I'm really trying to communicate the tinygrad. Yeah, we have depth-wise confs. Just depth-wise confs, sep confs are just like, the OpenPilot model uses them. They're just normal confs. There's nothing special about them. That's not a linear algebra op though. That's already supported. We have groups, strides, dilation, padding, and it works. I don't think that time is that bad actually. Let me remove the global params reset. And we can see what we're actually getting. Matrix decompositions and stuff. Again, if you can do these things, okay, so the place where we draw the line in tinygrad is on, can I do debug equals 1 and that works? Is on things that aren't addmul. If they're addmul and don't require load store, then I should output that with debug 1 too. You hear it? It sounds like a train. 1.7 teraflops. And 50 gigabytes per second. So no sorting, no. No sorting, no scatter gather. You don't need these things. Neural nets don't need that. Yeah, again, yeah, like linear algebra stuff, look how easy it is to implement. If it's easy to implement with kind of what we have and it's just some syntactic sugar in Tensor.py, I'm happy to add it. If it requires new MLOps and LLOps, whoa, that's a big deal. So tinygrad only has a few LLOps. These ones here. Like sign just got added and that was a big deal. But yeah, all right, so someone write that transpose, submit a nice pull request, make it nice. You know, some of you can like work together and like collaborate, like make it nice. Don't just do the bare minimum. Why would you wear the bare minimum of 15 pieces of flare, guys? Don't you want to express yourself? tinygrad has a Discord, but if you cannot find it, it's not for you. Don't tell him how to find it. Don't tell anyone how to find it. It's I'm so happy after raising money for tinygrad. I hope that's sarcasm, bro. I got the money. Like, I got the money sitting in a bank account, and I'm like, fuck, man, how do I deploy $5 million, you know? George, don't you think you should have had a plan before you raised money? Yeah, you know, but I'm not Sam Bankman-Fried. I don't know how to deploy large amounts of capital. I tried contacting the Miami Heat, but they wouldn't sell me the naming rights to the arena after they were burned last time. 5 million. Yes, that's gatekeeping. We love gatekeeping, but fair, honest gatekeeping. Not gatekeeping where you have to know, not steganography, man. Fuck steganography problems. Gatekeeping that requires like a little bit of, yeah. Yeah, we might get a house on the way. I don't know. We're looking. I think it's gonna be a house office. I can't show you. I have a prototype tinybox over here, but I can't show you the tinybox yet. The tinybox is a secret. But the tinybox is looking very. You guys are gonna be so happy if you buy a tinybox. We sell tiny boxes. The Tiny Corp sells tiny boxes. You can buy them at our website, tinygrad.org. You can pre-orders. They're $15,000. Yeah. I'm not Bobby Fischer, guys. I'm not going to move to Iceland and rant about how the Jews did 9/11. Respect Bobby Fischer, but I think that really did happen. Who leaked the server? Stop leaking. Why am I limiting my hiring pool? You know what? I changed the blog post. You know, I wrote this in the Discord. If you're in the Discord, you'd know. I changed my blog post. First off, the only way you're actually going to get hired at the Tiny Corp is if you've submitted pull requests for like a month. Right? Like, I'm in no rush to hire. I know I have to spend my $5 million, but I'm sure I could buy the naming rights to the Denver Nuggets. That can't be too expensive. I'm going to get on a plane to Colorado. We're going to have to charter a jet, of course, and I only fly Gulfstream. I'm not flying in a King Air. We're going to charter a Gulfstream. We're going to go to Denver, and we're going to spend Tiny Corp's money and buy the naming rights to the Denver Nuggets Stadium. Whoa, the WNBA, whoa. We raised more money than that, whoa. I saw a TikTok where it was like, yo, do you want these WNBA tickets or this dollar? Yeah. The Nuggets are winning, I know. Damn, I'm gonna have to go to the Timberwolves. They're not winning, are they? But yeah, so there's only one way to get hired at the Tiny Corp, and that's by submitting high-quality pull requests to tinygrad. I got way too many bad submissions for the programming challenge. Like, why the fuck are you even trying, bro? Like, this is not like a company with like 20 people in an HR department. It's like me. And if I look at your shit and decide it's shit, like, I'm not gonna hire you. Like, you're not like it's not. You know what? I have a friend who always talks to me about, like, I'll come up with, like, some, like, clever hack around the law. Well, you know, technically, there's no rule against keeping a live squirrel in your locker. Yeah, it doesn't matter. It doesn't matter, man. You're still getting detention. You can't keep a squirrel in your... It doesn't matter if there's a rule. Like, that's what I mean. Like, you're a well-actually. You're a well-actually middle curver. Technically, the income tax is unconstitutional. Exactly. The well-actually people. The well-actually people who try to do that. I'm like, don't pay your taxes and see what happens, bro. See what happens. Let me tell you, their guns are bigger than yours. Like Joe Biden said, they have F-16s and nuclear missiles. Do I do Europe remote, contract-based? Again, oh my fucking God. Like, it's like you're asking me a question like this. It's like, bro, I have $5 million. If you can legitimately help me spend my $5 million in a very frugal manner, because I'm actually very frugal and was kidding about the Gulfstream, we're going to have to drive in a Toyota Corolla powered by OpenPilot, where we get free gas sponsored by Shell because we put the Shell logo on the side of our Toyota Corolla. That's the real budget of the Tiny Corp, okay? And if you can show me that you can actually help me deploy this capital to meet the Tiny Corp's goal of getting AMD on MLPerf using the tinygrad framework, then I will pay you money, right? like, you know, this is something I'm going to talk about Twitter for a second. This is something like just being around that whole thing like showed me. It's like, man, if I think I'm frustrated, how do you think Elon feels, man? Like, I'm frustrated with you, you know. What about the 20% Intel chance? You know, look, we got to keep Intel in our back pocket, right? We got to keep Intel in our back pocket. Who knows? Who knows, man? Intel might let me borrow the company Gulfstream to go to Denver. Can I sponsor someone's visa? Like, bro, if you convince me you're going to create enough value, I'll pay for the lawyer. What, you want me to sponsor it legally? Sure, whatever, man. You know, I'll make you the intern of getting visas, and then you're the intern of getting visas, and you can get yourself a visa. Like, you know, look, America's immigration policy really pisses me off, but like, what, you want me to email back and forth with the lawyer? Like, bro, this is the whole fucking Tiny Corp, okay? It's me. And if there's a problem, it's me. That's right. I did buy a Rolls Royce, guys. I did buy a Rolls Royce. Unfortunately, it was not with the profits from Cheap ETH, because despite what the Hacker News haters think, I actually lost about $5,000 on Cheap ETH paying the DigitalOcean bill. I got a good price on a Rolls Royce. I'm actually very happy with it. I love this car. I just like every time I get in it, I'm just happy. It's so quiet on the highway. It's just they designed it. Like, the only thing that's disappointing about it is I didn't buy a new one because, you know, I'm cheap. So we get a used one, and the electronics are 10 years old. And like, yes, they were the best electronics you could buy 10 years ago, but they don't have CarPlay. Yeah, you can only put one GPU in a computer at a time because the drivers don't support two. You run a Lambo? Nice, bro. No, the Rolls Royce has hydraulic power steering and therefore doesn't support OPTLOCAL. It also has flex, right? But it does have adaptive cruise control. Okay. Yeah, so I will finish this tomorrow if somebody contributes and writes strides. And you'll be the hero of the stream. You'll be the hero of the stream. I'll make sure to reference your name at least 4 times. Or you can post in the pull request, please don't reference my name, and I won't. So yeah. And then we will finish the dcgan tomorrow. But for now, we're going to take Alex and we're going to go to coffee. Let's see. Oh, is Lana streaming? Oh, we should raid. Guys could check out Lana Lux. I put Lana Lux's stream on a couple days ago, so it was pretty nice. Nope, she's not streaming. She streamed 5 hours ago though. Oh, you just rated me. I was just, wow. That was wow. We were both gonna stop streaming at the same time. Actually, I watched your stream. I actually enjoyed it. You know, it makes me want to. I tried game development in one stream once, and I was really bad at it. Who's telling him? Wow. You know, you guys are gonna watch the replay, and I'm gonna look dumb. We gotta stream a little bit more then. Yeah, let's see. I tried. What did I try? I used Unity, and I had that's when I had my Razer laptop. You guys remember my Razer laptop? Let's try another tutorial. Oh, yo, no, I got Alex is like, George, I want to go to coffee. Maybe a brief overview of the Tiny Corp for newcomers. Okay, that sounds good. So I started a company. It's called the Tiny Corp. This is the blog post announcing our raise. We raised $5.1 million. $5 million from investors and 0.1 from me. The Tiny Corp is a computer company. We sell computers for more than they cost to make. And you say, well, doesn't every computer company do that? And the answer is all the successful ones do. The failed ones sell computers for less than they cost to make, and that's like the revenue company. Not a good company. So yeah, and limited to chip company, but there's a lot of intermediates along the way. The human brain has about 20 petaflops of compute. You can get that number by taking the 100 trillion neurons, 100 trillion synapses, which are kind of like flops, and multiplying by 200 hertz, which is like the fastest they can run. And I don't know, again, it's a rough number. It's probably not off by too many orders of magnitude. It's not perfect, but I would believe that 20 petaflops is a human brain. It also like intuitively makes sense when you've started to play with models of different sizes where you think like human scale might be. Yeah, also the language models actually are using way too little compute, and that's kind of interesting. Like, the language models have tons of weight but use very little compute, and they shouldn't, but whatever. We can get to that later. Wait, am I just trying to think about something? Shouldn't that be? No, the attention is okay. Never mind. Okay, with the way AI is going, we risk large entities controlling the majority of the compute in the world. I do not want to live in a world where there is a world market for 5 computers. This was, this quote? This is a famous quote by Watson, the Watson of IBM. In 1943, Thomas Watson, chairman of IBM, said, "I think there's a world market for maybe 5 computers." So, like, this is obviously absurd, and it's absurd to a lot of people, but then you start to think about it again, and now we do kind of have 5 computers, right? We have Google, we have Azure, Apple probably has a computer, Google has a computer, I said Google, Amazon has a computer. Yeah, so I don't want to live in this world, so we got to figure out how to make sure lots and lots of people can get chips in lots and lots of places. I believe Eliezer Yudkowsky called for shooting missiles at data centers. And the answer is we have to put a data center in everybody's house. And that's the only way forward to make sure that AI is never given over to the safety people, right? And it's not, and I'm going to talk, all right, you got me. I'll talk about AI safety for a minute, okay? You know what the most absolutely horrifying outcome of AI is? If OpenAI is the only one building a single unipolar AI. This is terrifying. These people talk about AI safety, and then it's like Trump level of stupidity. It's like, AI is dangerous. I alone can make it safe. No, this is terrifying. The world I would much prefer to live in, right? Like, you're not going to get rid of all the guns, right? So now you can ask the question, do you want only the government to have guns, or do you want everyone to have guns? And I'm an everyone should have guns kind of person, right? And AIs are even better than guns, right? Guns are just kind of like, what are you going to do? Shoot somebody? Like, kind of sucks. But AI, you can do so many things with. So I want everybody to have an AI. And this is the only way forward with AI safety, really. You're not going to stop AI. The last thing you want is a few unaligned entities. It's not a question of aligning the AI. It's a question of aligning the entity with you. Do you really believe OpenAI and Sam Altman are aligned with you? Bro, think about that. You know who I trust is aligned with me? My GPU sitting right here in this box. This GPU is aligned with me. You know why it's aligned with me? Because I fucking own it. That's right. You know whose GPUs are not aligned with you? The Azure GPUs and the Amazon GPUs and the Tesla GPUs. Maybe they're a little aligned with you. You can decide that. But this GPU is aligned with me because I'm holding it. Okay? All right? There's your AI alignment. But George, you don't know what the AI is going to do. Yeah, you're right. I don't. But at least I'm trying to make an AI that's aligned with me. You guys are trying to monopolize. You guys are trying to build the absolute unipolar paperclipper that you tell us we should fear, right? Like, is there any difference between only I should have AI, but you should trust me to not? No. You know what? You know what's a good defense against a paperclipping AI? Me having an AI saying, nope, I'm not going to be a paperclip, and I'm going to fight you with AI, right? Like, so this is the only way forward, right? The only way forward is to get AI out to as many people as possible, as quickly as possible. Think about it, right? Look at the cows, right? Have you ever seen a cow farm? Right? You don't want to end up like the cows, right? Like, bro, you really don't want to end up like the cows, right? Like this is not, I don't want to be that, right? That cow farm actually looks decent. I've seen way worse looking cow farms, right? Or God forbid, a chicken farm. You guys ever seen a chicken farm? Like, trigger warning. Yeah, you don't want to end up like that, okay? That's not what you want to end up like, all right? All right? That's not what you want to end up like. So if some of those chickens had IQ 150, they wouldn't have ended up like that, right? But the reason it ended up like that is because we're all smart and the chickens are all dumb, right? So if you don't want to end up like a chicken, you better start figuring out how to get AI and getting it yourself, right? Because otherwise, you're going to be like, why is it that probably the 10 people who work that chicken farm get to dominate all the chickens like that? And the answer is those people have a lot more intelligence than the chickens. Right? So you don't want single organizations getting all the intelligence. You want to make sure that you have some intelligence too, so you don't end up like the chickens. Does this make sense? All right? It's not that hard, and you're not going to die. It's okay. But make sure that you're not outsourcing your AI to somebody else. Because if you're doing that, you're going to end up like the chickens. Right? That's AI safety, right? Oh, well, what are we going to do about gun safety? Well, we're only going to give them to the government. Oh, shit, man. Oh, shit. See, that's how you get tyranny, right? Right? That's how you get tyranny. When the government fears the people, you have liberty. When the people fear the government, you have tyranny, man. When Sam Altman is the only one with AIs and just proposing to the government that they should not let other people get AIs because I alone can be trusted, that's when we have a problem. But as long as we can avoid monopolies on compute. I really mean this. This is my actual take on AI safety. AI is potentially dangerous. AI is potentially very dangerous. But the most dangerous, things that you should just throw out right away are this: we're going to stop, right? You can't stop technology. You will never ever stop technology, right? This just won't happen. This is in fact the only way to stop technology is with utter and complete tyranny, right? So let's just rule out anything like that right away, right? Hopefully we're on the same page about that. Okay, now you have two other options, right? Either we can keep the technology controlled such that only a few people have it, or we can give the technology to everybody. Now, keeping the technology controlled is not a bad idea for something like nuclear weapons, right? The thing about nuclear weapons is they can't be used tactically. And this is a huge advantage. Thank God for this, right? If nuclear weapons could be used tactically, the United States would have dominated the world in the early 50s. Right? We just would have taken over the whole world and that would have been it. But you can't really use a nuclear weapon tactically. And because you can't really use a nuclear weapon tactically, we really don't want everybody having a nuke. I'm not advocating for that because there's nothing you can really do with a nuke. Also, nukes are not defenses against nukes, right? If I have a nuke and you're nuking, it doesn't matter. Right? It doesn't help. It doesn't help to have one of your own. Maybe in some psychological war games, mutually assured destruction kind of way, but no, you can't. And we're gonna make the thing bigger because I'm talking. All right, cool. So you know what the defense is against AI? Do you know what the defense for those chickens would be? Let's look at the chickens again, because really, you do not want to end up like the chickens, right? Chicken farms, right? If some of those chickens were smart, if some of those chickens had intelligence, they could fight back against this guy, right? I'm sorry to pick on this guy. I know you're just doing your job, man, but what does this guy have over the chickens, right? And you think, oh, the guy's bigger. That's not really the problem. The problem is chickens are stupid, right? So this is the world where, OpenAI has the AI and everybody else is just plebs connecting to their API, right? Right? Not a good world. Oh, you can't see the photo? Oh, I'm sorry. Now you see the guy? There he is. There's the guy. There's the guy, right? Right? That's not the world we want to live in. All right? Let's look at another world. All right. See how both sides have spears and flags and stuff? I'd much rather live in this world than live in this world, right? All right. So there's no going back. There's no getting rid of the technology. The only thing you can choose is, do you want to live in a world where you have a fair fight, or do you want to live in a world where you're the chicken? Right? That's it. No, you just gotta make sure. Yeah, look, as long as it stays, as long as basically like, if one organization or few colluding organizations get all the AI, we're fucked. We are fucked beyond belief, guys. But as long as like, if like 10% of the people in the world can all gang up and have more compute power and more intelligence than the large organizations, it's fine. Right? That's actually going to determine whether the future turns into liberty or tyranny. Tyranny also doesn't last forever, so like, it's not all doom and gloom even if you're in the chicken world, right? Like, it's bad for the chickens now, but eventually when all the humans kill themselves with AI, things will look pretty good again for the chickens. So I'm just saying. Tyranny doesn't last forever. So even if we do live in a bad world, it's not forever. But short term, what can we do? And the answer is to get everybody in there. You want to go get coffee? Okay, we'll go in a little bit. I'm telling them about how not to be a chicken.
I'm ready to go right now.
Do you want to look at the chicken picture?
Yes.
All right, come look at it. I'm on stream, and then we'll go. We just got to tell them that this is what happens if we live in a world where the only training computers are owned by large organizations unaligned with your interests. You need to buy my computer and not be chicken. Exactly. No. Come on. I'm not gonna. I do really believe this. I'm not just using this as an ad to sell computers. But it's 1984 ad, right? We bunk, not chicken. Alright, so yeah, we raised money because I don't want to live in a shitty. I don't want to be the chicken man. We gotta build chicken exoskeleton suits. We gotta fight back. Cloud gaming, guys, you will eat the bugs. You will live in the pod. You will rent everything, and you will be happy. No, you will buy a tiny box. Don't rent it. It's your tiny box. Hello. I'm explaining to them that they don't want to be chicken, right? This is what happens in the world if one entity has all the intelligence and the AI and everybody else just has small human brain. Why does he rule the chickens? Why? It's a good question.
He's chicken king.
What would it take for the chickens to rebel? And if you think that it's the chicken's size, may I remind you about cow farms, right? People are like, oh, well, chickens are only owned because have you seen the size of a cow? If the cows were just a little bit smarter, just a little bit.
Yeah.
It's all AI, guys. It's not your size. They're way bigger than a human. Look. Like, bro.
Cows are pretty smart too.
They're not that smart, right? You don't see cows, coming together and like making steel and making. I'm talking like if cows are mad smart. Think about it.
I got like cash down there.
Oh, my large stack of ones.
With that.
No, but think about it.
I have thought about it.
Right? If the cows were like, imagine the cows were like 10x smarter than humans. Like, we'd be fucked.
This is why the EAs.
The cows.
This is why the EAs are all vegan.
Wait, yeah. This actually makes sense. Like, they have this chronic misunderstanding of power. They just but don't worry, the cows aren't actually smarter than you. You can eat cows and they're never gonna do shit about it because they're dumb. Yeah. No, they do. What do they think? They think that like
that's gonna be us.
Wow, they think that's gonna be them.
Yeah, and they're sending
because they don't see themselves as alpha, they see themselves as beta. Wow, it all makes sense. No, it doesn't have to foom, man. Nobody foomed. Humans moved up slowly, and we came to dominate the cows. All right. So look, All right. So that's the Tiny Corp. Look, it's not actually a philosophical crusade. It's actually a company writing some open source machine learning software. You guys can contribute to it on GitHub. I went through a tutorial today. It's a pretty good stream. Stop trying to look smart because of my glasses. No, it's because I have an astigmatism, and I don't want to talk about it. You guys, you know, you guys can.
Glasses today.
My eyes were hurting.
Oh.
Yeah. Yeah, are we already in a cage? A big cage called Earth, a big cage called this universe? Yeah, and God put us here. Do you know why God put us here? Because God's smarter than us. Now build the AI, and we can go talk to him about it. We can negotiate a better deal. It wouldn't even have to come down to a fight if we got smart chickens. You know what I mean? They'd figure out, you know, oh wow, no, that's an analogy that's not appropriate to this stream, but like, you know, chickens will sell other chickens into slavery, right? Like exactly, right? You just make a deal with the head chickens. You have a bunch of oligarch chickens, and it all works out, right? Like if the chickens were smarter, they could just negotiate. It'd be fine. But they're not smart, and that's why all the chickens are not, right? Is Scale AI open source? Scale AI is a CIA op. Scale AI. Look.
I don't know how to tell you this.
I don't know how to tell you this, boys, but whenever a startup is getting invited to the White House, it's a CIA. They either look. I don't think OpenAI is a CIA op, but like if you've never heard of them and they're getting invited to it's a CIA op. Okay. Cool. So yeah, no, we're writing an open source machine learning framework, and we're trying to make AMD competitive. Look, guys, it's a long game, okay? It's a long war. There's like lots of moving pieces. It's a 4D chess game, right? You know what I mean? So we build the framework, we empower the other GPU companies. Our goal at the Tiny Corp is to commoditize the petaflop. If you could walk into any CVS and right next to the Wrigley's gum, there's petaflops of compute, this works great. And you know what? There's no gum king, right? There's nobody out there. Like the gum is actually decentralized, man. So we just need to make the petaflop the same as the gum, right? Like there's probably a few warehouses, and those warehouses are fine. But if everybody brought all their gum together, it'd be more than the warehouses. And that's all you need. That's all you need to not end up in tyranny. I didn't say cows have a misunderstanding of power. I said effective altruists have a misunderstanding of power. Yeah, we're playing a long game, guys. We're playing a long game. Okay. So we buy these GPUs, and we make software that makes these GPUs work well. And you guys can contribute. It's on GitHub, right? So we like raised money to do this. There's a lot of ways to make money if we can actually succeed at this. Read the blog posts, and you can also buy tiny boxes, which are lots of these in a box. Which is actually like you think it's easy to put lots of these in a box, but it's really not, right? Like because these are very big, and they don't really make boxes that big. And you're like, yeah, but I can buy a really big box. Yeah, but how are you going to connect this thing, right? You got to connect this thing, and the box is too big. And, you know what I'm saying, right? You can try it. You can be like, damn, that's hard. I'll just buy a tiny box. All right, cool. Thank you for watching today's stream. If someone writes stride, I'll be back on tomorrow to finish up dcgan. And I'd love it if you all collaborated because together we can stand strong and make sure we do not end up as the new chicken. Thank you all for watching.